Example number 2. The pipe in figure 244a is subjected to the force of F equals 80 pounds. Determine the angle theta between F and the pipe segment BA and the projection of the vector F along the segment. Okay, let's get some room. I guess this room should be enough. So the first thing we should do is to get the vector, or the vector representation of segment BA, which is this. Let me get my green color. Segment BA. Oh, what? Segment BA. That's segment BA. That's segment BA. Now it's a vector. Now, how how do what is the value of the vector? So as you can see, there are some values here, and we could get the value of BA. So it looks like it has a z component of, so it goes up 1 feet, 1 foot. It goes up 1 foot. So the vector BA, not T, BA is equal to, z component looks like it went up 1. I'm not gonna write the units. Well, actually, maybe I should write the units. Feet. That's feet. Uh, it went. Looks like it went. Hmm. Looks like it went 2 feet to the left. To the left in terms of the y-axis. Is that right? Yep. So -2 for the y component, and it went back. It went back to. It went back it went back to in terms of the x-axis, so -2 for the x component. Alright, so that's BA. That's one thing checked out of our checkbox, I guess. And we want to know what is the direction of F, the vector F. It's here. So what is the direction of F? Well, it's going to be some direction. Or what is vector F? It's going to be the magnitude of F, which is 80. Let's just write 80 times some direction. Let's just call it the unit vector. Some direction. Let's call it x for now. So what is this? What is this? Let's change color. What is this? Well, as you can see, the vector F is kind of along a segment BC to be exact. Looks like it's about the segment BC, so we could get the unit vector by getting the this vector. We could get the unit vector by getting vector BC, dividing it by the the length or the magnitude of the vector. So that's going to be relatively easy. So B went up 1, so BC. Let's change color to yellow. B, BC, BC equals, it went up by 1, it went up by 1, it went up by 1, went to the left in terms of the y-axis by 3 feet, by 3 feet, and It didn't change in the x direction, looks like. Yep, whoops, accidentally hit the home button on my phone. That's quite funny. Alright, 0. That's vector BC. So we would want to get the unit vector x. In this case, I'm going to name it unit vector. Let's change colors. Let's choose this color. Let's say instead of u hat x, we write it as u hat bc to be more descriptive. Alright, let's solve u hat bc, or unit vector bc. It's going to be equal to the vector itself. Alright, let's choose white. The vector itself, bc, so let's choose yellow. 0, comma 3, comma, 0, comma, negative 3, comma 1. Double check that again. I have anxiety issues. Seems correct. Divided by the magnitude of the vector, which is 0 squared, which is 0. I'm not going to write that down. Negative 3 squared plus, that's 3, plus 1 squared. This is the square root of 10. This denominator part of the fraction is square root of 10, which means that the component, let's choose another color, or the unit vector, the unit vector along the BC direction is simply 0, comma, negative 3 over square root of 10, comma 1 over square root of 10. Let me write it as square root of 10. Actually, never mind. 1 over square root of 10. 10. That's unit vector. That is unit vector BC. Unit vector BC. So with this, we could calculate the vector f. All we have to do is, let's get green color. The vector f is equal to 80. All right, 80 times 80 newtons. Is it newtons? No, it's pounds. All right, pounds times the vector 0, negative 3 square root of 10, comma 1 square root of 10. Maybe should have written that in this color, but oh well. So it's going to be equal to the 0, negative 240 over square root of 10, comma 80 square root of 10. That's pounds. All right, can't forget the units. That's vector f. That is vector f. Let's box that answer. That's vector f, but remember the question is asking determine the angle between f and the pipe segment BA. So we can use what do you call this formula, whatever this formula is called. Let me write it down in this color. Alright, A, this time it's not cross. A dot B is equal to, oh no, the magnitude of A times the magnitude of B times cosine theta. Cosine theta. Is that right? Huh. Oh, okay. So the magnitude of all right. Wait. Let me read. So it's going to be F, the force vector, times, oh, not times, dot, B, the vector BC. The magnitude of F is just 80 pounds. 80 pounds, let's not write the units anymore. Times BC, what's the magnitude of BC? It's going to be the square root of negative 2. Let's write that down in this color. Square root of negative 2 squared. Square root of negative 2 squared plus negative 2 squared again, I think, plus 1 squared. Is that right? Negative 2, negative 2, and 1. Yes, it's correct. So switch to green and get cosine theta. Cosine theta. Cosine theta. And now let's get this F. Let's try and copy paste it. Let's try and copy paste. Let's try and copy paste. Copy and paste. Alright. And green vector. Oops, green. Oh no. Alright. Supposed to be square root of 10 square root of 10. Is that correct? Yeah, it's correct. Dot 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 alright, dot bc which is going to be negative 2 comma negative 2 comma 1. Now we do some multiplication. Negative 2 and 1, that's correct. So hopefully I could get the answer fast. So the first component, the x component at least, is 0. That's easy. And let me solve for what's I'm using my calculator right now. So 240 over square root of 10 times 2. The negatives cancel, so 48 square root of 10 is 151.78 point, no, not 78, 79, rounded up in this case, and 80 square root of 10. What's 80 square root of 10? What's 80 square root of 10? 80 square root of 10 is 25.30 rounded off. Now we plug it into the equation, this equation. I don't want to rewrite everything, so I'm going to copy paste again. Hopefully, nope. Hopefully it recognizes it. What? Never your mind. And copy, paste. Hmm, it's here. Should be here. There we go. So this is nothing. This is 80. Oops. This is 80. This is correct. Cosine theta. Now we solve for cosine theta. Wait. Oh no. Wait. Oh, my bad. I forgot dot products are scalars. Alright, it's 151.79 plus 25.30. 151.79 plus 25.30. 177.09. 177.09 divided by 80. What's square root of 2 squared 4, negative 2 squared 4, negative 2 squared 4, that's 8, 9, this is 3. This is 3, so 80 times 3. Uh, let's do it all in one step. Our cosine, our cosine is equal to theta, and theta is equal to, this is times, let's get our calculator, 177.09 divided by 80 times 3, and 42.45 degrees. 42.45 degrees. That's one of the answers. And the other answer, let's go back to the question. Whoops, looks like I made a mistake. The mistake I made when I first calculated the projection of vector f along the segment BA, is that I multiplied the magnitude of vector f with the unit vector BA. Now that is not correct. Why? It's essentially instead of this, you can think of it as let's get the same color. That would be this, the same length as this, the same length and magnitude as this. You can think of it as length and magnitude are the same in this context. So this would be f BA in how I drew it. So that's no good. That's no good. What I meant to do, what I meant to do was take it take the easy answer, I guess. I could I could just take the cosine. The cosine theta times the magnitude of this, the magnitude of this, which would be correct. Alright, let's draw a perpendicular line. And the angle between them is, again, it's 44.45 degrees. Can't remember. It's 42.45 degrees. So the answer is, so how it came to be, of course, let's do it step by step. Going to be f cross a certain, oops, not cross, dot a certain unit vector, ba in this case, is going to be equal to the magnitude of f times the magnitude of the unit vector ba times cosine theta. While the unit vector, the magnitude or length of the unit vector is 1, so we just have to take the magnitude of the force vector, which is 80 pounds to be exact, times cosine of the angle between them, which is 42.45, 42.45. 80 times cosine of 42.45 is 80 times cosine of 42.45, 59.03, rounded off to two decimal places. It's going to be 59.03, 029325957, but let's round it off to 59.03. Let's put in pounds here, and we're done.